Now let's start with the fetch phase. Fetch. So fetching is nothing but getting the instruction into the instruction register. Where is instruction present? It is present in the main memory. So assume that before we start anything, the program counter is going to be loaded with the starting instruction address. If the address is if the program is starting at address 100, then program counter should contain address 100, and before you start any program, generally you clear the sequence counter. Then what happens is automatically T0 will be generated, or T0 will get highlighted. Got it? So when we start, we are going to start with T0. T0 is nothing but what it represents is we are actually at the beginning of the instruction cycle. That is the meaning of it. Then what we do is we have to move program counter into address register, because we have to get the instruction from the memory. So we already seen it, but again I am saying it so that we can construct the circuit here clearly. So what we are trying to do is at T0 into the that address register, we are going to move program counter. So assume that before we start this, program counter is already loaded with the starting address of the program, otherwise we cannot start the program. And also assume that now we are in T0. Okay, then after that, this happens in the first clock cycle, right? So if you want to see what has happened here, clocks are given like this. Okay, and so when I talk about T0, it means that this is the first one. So T0 is activated. So it is all happening during this time. So this is T0. So T0 is active during the first clock cycle. So how can I say that it is first clock cycle? It need not be first clock cycle, but we are assuming that it is first clock cycle, because before this also there must be many clock cycles which have gone, right, which are already over. So when we started this program, we are counting from here. Wherever you count from, wherever you start counting from, that is what we are going to call as T0, isn't it? See, even the time and days also we are going to actually count with some point as a reference. It doesn't mean that before that point there is no time or something like that, isn't it? If you assume that universe has started at some point, and if you are going to count from that day one, it doesn't mean that before that day one there are no days, isn't it? So before this T0 there were many clocks, but actually we start counting from here, right? And with reference to this we do all the other activities. Got it? Now what happens is during this clock we want to perform this operation. And when will this operation be exactly performed is, try to understand this one. Now we are going to have, one is program counter and other is address register, isn't it? So what are the signals that you have to give? So other one is we have the bus, right? So bus is having three signals, S2, S1, S1 and S0, and this is the bus. And to the bus all these are connected. We have already seen that, right? Like this. Now what should happen in order for this to happen, right? So we have some timing circuit here. From this timing circuit we are going to get the signal T0. So at T0, output of PC or whatever is present in PC should come on to the bus. So that is why PC has to be selected, or the data of PC has to be selected by the bus. So for that reason your bus has to activate this, and we know that PC register will be selected when S2, S1, S0 or 0, 1, 0, which means to this particular S1 I have to apply T0. So assume that this signal is T0. Okay, why do you think I am writing a OR gate? Because it is not just at this time t0 we are going to use this s1. Later at some other times we might want to use it. That is why I am just using the OR gate, so that whenever we need it we just connect to that, right? So now what happens is, essentially at t0 this one will be 0, this one will be 0, and only this one will be 1. So because of this, immediately whatever data is present here, that will come onto the bus. Now since it is present in the bus, it will be present at the input of every register, and so it will be present at the input of AR register also. Got it? Now at the same time even the load input of AR also should get t0, because AR has to be loaded. Therefore let us assume that this is the load input, and this is also having an OR gate. Why OR gate? Because some other instructions at some other time also might want to load something into AR. That is why this one. So now what happens is, exactly at this point, if this is t0, exactly at this point whatever is present on the bus will get onto AR. Therefore by the end of t0, or whenever it sees the next clock cycle during t0, whenever these two happen, our data will be loaded into AR. So data is in AR. That is the meaning of it. Now after this, at t1, let us assume that this is over, right? At t1 what should we do? We have to take from AR, we have to give AR to the memory and read that particular instruction which is present at this address in memory into instruction register. Therefore we are supposed to have one more register. We have it already, instruction register, which is also connected to the bus, and assume that this is the memory which is also present. And now to the memory I have to give the address register address. It is already given. Got it? Address will go into the memory, and memory is also connected to the bus. Now we know that if you have to read something from the memory has to be selected, isn't it? So we have to give a read input to memory, as well as we have to enable the bus to take that into the this one bus. Got it? So we know that in order to read something from memory onto the bus, the select inputs for the bus should be 1 1 1. Therefore here to this one, and to this one, and to this one, to all the three I have to give t1, right? Therefore t1 is going to be given to all the three. What does it mean? At time t equal to 1, at time t1, all the three will be selected, which means output of the memory will come here. But then you have to enable, or you have to give the control signal for the read. Therefore at the time t1 we are also going to give the read input here, right, to this OR gate. Let us say this is the read input. We are going to give the t1. Then what happens is, memory will be enabled for reading, and then whatever word is read, that will go on to the bus. Now that is available at all the inputs, including this input as well. But then this has to read it, right? That is why at the load has to be activated at t1. Now what happens is, from memory the word will come into the bus, and through the bus it will enter into the IR. So we have taken t0 and t1, these two clocks, in order to execute this first phase. So the first phase fetch has contained or is performed in two cycles, t0 and t1. At t1 itself we can also perform one more thing. We can perform PC equal to PC plus 1, which means we can increment the program counter. Why are we doing this? Because the next time when we fetch the instruction, we will be fetching it from the next point, isn't it? If the first instruction is present at 100, the next instruction will be present at 101. That is the reason. So that is why I am just incrementing it. How can I increment program counter? If we have program counter here, assume that it is also present and connected to the bus itself, there will be increment, isn't it? Increment is also a control signal which is present for program counter. Now to this control input I am going to give t1. Therefore at t1 it will be incremented. Got it? Now why can't I put it here? If I put it here, then it might lead to some problem, because before transferring PC into AR, sometimes it might get incremented. That is why I'm placing it here. So what can you understand from this? Fetch cycle, the fetch phase can be implemented in our computer, in our basic computer, in 2 clocks. So it actually varies from computer to computer. So in the exam they are going to specify how many clocks it will take for you to execute each phase. In our example it has taken 2 clocks. Got it? Okay, now let's go to the decode phase.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into university is better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.